Let us now conclude our lecture with our understanding of what we have discovered. Summary of Tableau 9 Part 1, a first look at independence. Probabilistic or mathematical or statistical independence captures an informal idea. Informally, we will say in ordinary language that two events are independent if the occurrence of one does not affect the occurrence of the other. This is informal. The formal mechanism we will put into process here is the following. We say that events A and B in some probability space are independent if a rule of products is manifested. The probability of A intersection B is equal to the probability of A times the probability of B. Whenever you're asked to check independence or verify independence, you should promptly write down that identity and ask, is this true? Calculate each of the probabilities for A intersection B, for A, for B, and ask, do we have an identity? Do we have a rule of products? If you do, then the events are independent. If you don't, they are not. We saw that an immediate consequence of this definition is that if events A and B are independent, then so are A complement and B, and so are A and B complement, and so are A complement and B complement. It's very natural, very intuitive. The independence of any pair, it will imply independence for any combination of complements. We looked at another variation on this problem by asking what happens if there's conditioning. Events A and B are conditionally independent given an ancillary event C if a rule of products is manifested for conditional probabilities. We saw an example where this kind of conditional independence arises naturally in problems. A high-level idea of where this arises is where you have a problem where you have many initial choices, many pathways, many roads that could be followed. A road is chosen first, and then you follow the characteristics of that road. This is the kind of setting where conditional independence is usually manifest within the problem structure. But you bear in mind our slogan that conditional independence does not imply independence. And of course, nor does independence imply conditional independence. This concludes Tableau 9, Part 1. What we have done here is establish the foundation for a mathematical, clean, simple, elegant definition of independence. The second part of this tableau will take this definition and look at abstractions. Look at settings where we have many events and try to find simple, clean ways of figuring out when independence is baked into the structure. This will be the content of Tableau 9, Part 2.